on a population. So let's say we know like the mean and standard deviation, and the standard deviation. We should have a full control. A full control on the sample side. Any sample we pick, right? And any sample we pick. As long as it has like a large number and of sample size, so it doesn't really matter that the curve that's followed through is always basically it's always like approximately to the normal curve by the central limit theorem. So I don't really care how many samples that we pick. If it is the normal curve, we can pick like 5, 10, or 15, or something like that. So we can always find the probability along the way. However, we come from chapter 7, which is objective 6. So if we have a full control on the sample, of course, that we always have that of a sample. So we know like the X bars, and the sample standard deviation. And the sample standard deviation S in this case. So we have a partial control. Partial control on the population, right? So we can actually estimate the mean, right? The population mean. This is what we have for the population average. Using the z-score, the z distributions, or the t-score. Okay. So for the z-score is not something that very realistic, but it's still be on the lectures. The z-score when we know the population standard deviation, which is that one. And then this can be computed by X bar. Plus and minus. The standard deviation, that like a z times the standard deviation over radical n. Radical n. And then when we have like a very small sample size, when it's come to a small sample size, and especially when the population standard deviation not known, we have to use S, then the sigma is not known yet. It's not known. Then we use S, the sample standard deviation. So then the estimation can be estimated can be computed by X bar plus and minus. T times S over radical N. And then the estimation must be on two-tailed, right? Two sides. Which is the upper limit and the lower limit, right? In other words, we estimate on the upper limits, on the lower limits, the worst, and the lower limit, and the upper limits of the interval, right? So the mean must for like the population mean may fall into that interval at like 95% confidence or 99% confidence, something like that, right? And then 90% confidence, so on and so forth. So there's no guarantee that the means will follow through it. We fall within the range. However, it is come so but the likelihood the population mean, which is the parameter, fall out of the range is low, right? So the risk that we take is much low. This is what we have for the definition. So I understand that this might be a little bit hard and challenging to understand what it is. So apparently that we can for chapter 8, which is on the objective 7. So the likely we are going to conduct the hypothesis testing. Okay. So we're not going to setting up the interval of the estimation, but we are testing a certain value. Okay. So, for example, can give you that. For example, we have the average grade for the second exam in this class, right? Assume L class follow the normal curve. And it is considered a good sample size, right? Of course, our class cannot be considered a good sample size because, like I said, it have to be randomly picked to be considered like a good sample. So let's say the second exam average, which is X bar equal to
Professor, can you let Jasmina in the Zoom?
I'm sorry. Oh, okay. I just unmute her. Yeah, somehow I just want to teach, and I have to keep on, go back and forward to meet more people to the class. All right, so we're gonna have the X bar equal to um let's say um I would say like 65, something like that, or 67, right? And then the sample standard deviation is equal to like 3.5 points. So given by our class size, assuming our class is a good sample and equal to let's say we have 20 students, but 27 students who took the exams, meaning that we have one student not taking the test, but doesn't matter. So we want to estimate. So we can't. So instead of estimating the interval, which we can get it done, which is we're gonna take x bar plus and minus uh t times radical, something like that. We can also test if the population average, if this guy. So remember, if we use our class as a sample, meaning that the population mean must reflect on the entire stat 113. So this one going to be the average grade for all student in stat 113. Okay. Yeah, so we can't test on that. I want you to know the if the average grade for the entire stat 113 will be let's say greater than like greater than like 64, something like that. Oh, you want to have the mean uh, you know, let's say the mean was oh, you want to have the mean was less than 70 or something like that, with just C minus. So, so instead of just setting up the interval, and then we actually going to conduct that test to serve our goal and purpose. So we're not gonna estimate the entire confidence interval. So I want to know if the average grade was basically less than like a C minus, something like that, or it's greater than like a D plus, right? So this is our job to get it done. So we're going to do the hypothesis and so on and so forth. Okay. So the hypothesis testing is very important because it must follow through that procedure. Um, so hypothesis testing involve 4 different steps, like separate steps. So the first one, you need to set up the hypothesis. There'll be 2 hypotheses that we're going to deal with. The first one we call the HO, which is we call the null hypothesis. Okay, so that one is basically where the confidence interval that based upon. This is what it's very similar to the confidence level, right? This is what we have for the confidence level. And then the second one you call HA, which is H1, whatever you want to call it. So this is what we have for the null hypothesis. I'm sorry, the alternative hypothesis. So this is like going out. So this is like different, right? It is like opposite of HO. Okay. So and then the second step that we have to get it done, we go into compute statistical value. So there are so many ways we can do it, but for chapter eight only, that we're going to use either the z-test, which is what we have learned uh from chapter six or objective five. So this is the main thing. It's, I mean, knowing what the curve looks like for the sample is very important. So we might have to subtract the mean and divide it by the standard deviation over radical n. So we have learned this before. And then, or we can also do the t-score if the O is not given. So this one is the population standard deviation is given. And then x bar minus the mean, we just literally do the same thing, but instead of let me just copy that. So this one x bar minus the mean over S divided by radical n. Okay. Oh, we might have to do like P or something like that. So, or P. Um, I know it's somewhat is this is what we have. Learn it. You're gonna take the P hat minus the P over over the square root of the P times 1 minus P. Oh, PQ, whatever you want to call it. Oh my goodness, I don't have enough space for this. Over N. Okay. And then the next step, we're gonna find the critical values of p-value. Okay. So this one must be done on the calculators. Okay. And or the table. So I'm definitely gonna show you how to do that. And finally, you're gonna need to compare whether we reject or we do not reject or fail to reject make decision on HO. Okay. So this one is whether we need to compare critical values or with the statistical values. Are we going to find p-values and compare with the significant values level? All right, so I know it's somewhat like we have to follow like four different steps right here. So the step one, you have to write up the hypothesis. Step two, you have to compute a statistical value. And so this step is basically involving like one test or two tests. So one or two tests based on what we have, we'll show you what it is. And then next we need to find the critical value of the p-value, and finally we need to make decision whether we're going to reject HO or fail to reject HO. Okay. So let's say we go back to the problem previously. So let's say we have estimated the mean was 67 and we 3.5. So I just wanna rewrite this and just making sure that people understand what it is. And then we have like n equal to 27, for example. So if we compute the confidence level at 99% or 95%, something like that, that gives uh the average mean for the entire uh campus was, let's say, about between 62 up to 60 up to 72 or something like that, right? Okay. So if we test, so meaning that, so the population mean can be any points, can be any values that runs between 62 and 60 and 72. So this one we have no kind of information, right? So we have no information. We have no information if the average was between uh, 62 and 72. So it can be any value. So it can be 63, it can be 64, it can be 65, it can be 66, it can be 67, it can be 68, 69, 70, 71, and 72, right? So we have no kind of information. So if we test on the means, so let's say if we test on the mean, on the mean, uh, like greater than 60. So that makes sense, right? So this one check, right? This one's good. We're going to accept it. Okay. The reason why because the lowest point of the average, because the lowest estimation is 62. So that basically beats 60, right? Obviously. But if you test on the mean was like about between like 62 and 70, let's say I want to know if the mean was like less than 66, for example. I'm sorry, less than 70. So this one we cannot say anything because, like I said, the lowest point will be 62. So you can't, the average you can turns out to be like like 71 and 72. Of course, the test power going to be much lower compared to 61, 62, 62, 63, 64, 65, 66, 67, 60, whatever it is, right? So because the population mean, the population mean can be average, can be like 671 or 72, something like that, or 71.5, something like that, or 72, whatever. Right? So we can't say anything because those value basically greater than 70. So when we test any value that between the confidence level, so we do not like do not accept this hypothesis, right? Because it's always come with the likelihood and then the probability. So when we have for the hypothesis testing, on the other hand, um, so we're gonna have to set up the bound like between uh 62 up to 72, whatever it is. So we can compute it quickly, up to 72. So the mean can be anything between 62 and 72. So we can't say anything for that. So we call this one HO, the null hypothesis. So we have no information at all. So we have no information. We have no information uh, on the null hypothesis, right? So, and we can only accept the value when you test like the mean was, hey, the mean was any of these region we call critical region, something like that. Is coming from, of course, this one is very similar to that. It's coming from a sample. And then you can think of that. Let's say the mean was greater than 60. Of course, any point that we test on 60, that's going to be accepted. The likelihood that it's going wrong, it's basically much lower. And yeah, this is what we call a type 1, type 2 error. We definitely go over it. And then any point that we test on the mean was less than 75, 76, 77, so that will be accepted at a very low risk. So this two region we call critical region. So the confidence level going to provide you like the shorter the range, the more information that we know, right? And then any when we test on any points between 62 and 72, we basically good not going to accept that. So we're going to accept this region at any point. Any point, any hypothesis of the hypothesis on this region, based on a certain risk, based on the certain risk, that we take, which is called the significant level. So this is what we call the power of the test as well. Like if we take like 5%, meaning that even if we going to say yes, right? So for example, we test on a mean was greater than 60, it's a yes for that, but we still have 5% chance that it might not basically greater than 60, right? So we always have to associate with the risk that we're willing to take. Um, okay, so significant level usually can be computed like, uh, but usually will be given for the question, so you don't have to worry about that. Hey, how can I find significant level, something like that. Of the hypothesis. Okay, so let me just start off this one. All right, so this question is simply asking us to compute uh the ZT test, right? So let me just start with that. All right, so the question says we have a sample mean of 27.3. And so this one Explorer equal to 27.3. Then we want to test if the mean was different from 6.8, something like that. So when the sample size was like 18 or something, and it is coming from the unknown population standard deviation, then we have to always do the t-test. And even if the size would go to 80, and then we also have this one, which is that. And then we're gonna use t. This one gonna do z. As simple as that. It just um so that means that we're gonna have this one, you're gonna s. Okay, so we have to use the t-score. Okay, and then we need to compute that as well. I think we need to compute the t-score based on the form that we have, which is what I wrote earlier, so the t equal to um, so we simply take the sample mean, which is equal to 27.3, minus, let me just do on a calculator. So just making sure that we don't have to write them down on the exam. So we're going to take divide first. And then on top of that, I'm going to take the sample mean, which is 27.3, subtract the population means that we had was assumed 60 26.8, and then we divide it by the sample standard deviation is 3.8 over the radical ends, which is radical how many people do we take? 18, sample size 18, so we're gonna do that. And then that should give us the answers equal to 0.558 or 0.556, whatever you want to call, or 0.56. Okay, that's perfectly fine. And then we do the same thing for z-score. So, but instead, um, what we have like taking the sample size equal to 80, for example, if the sample size is big enough, usually the difference between T and Z score just doesn't matter that much. The T basically converts to the Z's, so it doesn't matter. We can also take the sample standard deviation to compute it. Um, so let me just plug that in. So we do have the formula right there. Just yeah, this one. So so we just use a calculator. So we have first you have to hit divide, and we take 27.3 minus 26.8. Since the question does not give us the population standard deviation, but it does like 2.9 and over the square root of the sample size equal to 80, and then you're gonna get the answers correctly. So in this case, what you want to uh, so either way, like whenever you do, you have to passively resolve this to just take all four of these and then we should be able to get you should be able to get the answer will be 1.54. Okay. Okay. You want to split these into their prime factors, right? So if you have x squared, you want to divide it another down x times that. All right. So any questions, any concern? We can try different example, just in case. So let's say we're gonna try another one. So have no population is the z score you can just, and this one is unknown. You have either t, you can compute it. Okay, something like that. All right. Um, it's normal curve, z score, and this one t. Yeah, I'm trying to try something that is maybe unclear for the question, but I don't think so. All right, all right. Let me just move up to the next example. So we have to determine the null hypothesis test. So first we go into derive the H1s, which is HH, an alternate hypothesis. So this is something that we have to based on what the question asks, what the question is testing. Okay. So let's say um the question's sort of testing if we have to identify the keyword for that. It's greater than last year's mean, so we're gonna test on the mean was greater than 7.5. Okay, but the majority of the test is based on a confidence level, which is no hypothesis. This is where we have no information. So since we have no information, we can write anything. Somehow we just write like the opposite, less than equal to from the alternative hypothesis. But most of the stat 113 they going to set equal. That's perfectly fine. So yeah, this is what we're going to write. The bottom is based on the keywords, which is greater than last year. The top just set up equal. Okay, so that's what it is. And this is basically the one tail test. So one tail test is basically test on um is test on the get the size greater or less than. Okay. And the two tail test is simply test on like different, test on like not equal to different, not equal to. Something like that. Are we good? All right. When you try to put it um on your assignment, just making sure you're gonna use means. No, no, no. I'm sorry. You have to do this one first. The bottom is have to be greater than. The mean was equal to greater than 7.5. To put that 7.5 that on top of that, we just hit equal. So the mean was equal to 7.5. Okay, simple as that. Any question? It's a very straightforward, just something that. So you can try another one. Let's say, you know, we need to read the question, see what the keywords is. When you plug that in. So smarter, like so the keyword is smarter, so we have to be greater than that in terms of the IQ test. So we're gonna put the mean was greater than 110, 16. And then we just do the same thing. So just yeah, the top just like equal. Since the question always give me a similar question, so I just do it a little quickly. Okay, so the same thing, we're gonna identify the score higher, so it had to be the bottom had to write the bottom hypothesis first, so that be had to be greater than no the bottom had to be greater than the mean was greater than 478. The bottom the top will be equal to 478. Okay, I think that's about it. And then yeah, so now we're going to determine the critical values based on the alpha, based on the significant values. Um, so this one is going to be like using critical method, or we can use the p-value approach. It doesn't matter. Let me just show you what it is. All right. So since we have we just computed like the test statistic. Um, so what are we trying to test? We're trying to test if the mean was less than 7, which is on the left tail. And then we're using alpha, which is 10%, that we're willing to take 10% risk. Um, some people might take like 1% alpha, so that you want a report to be extremely critical, extremely like good, like valid, but there's nobody actually taking like the alpha equal to 60%, like zero point 0.6 or something like that. But there's nothing wrong with that, but you're gonna facing like a higher risk of like, you know, for 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 the test. So if you take like zero point 0.6 level of significance, meaning that our decision will be only 0.6% correct, 60% correct. Basically, you're facing 40% that is gonna fall out. Okay. So now we're gonna just compare the score that we have over there. So this is basically one tell because the keyword less than, so it's one tell test. And then that we're going to have a enter critical values that we just have over there. This negative 1.282 and enter statistical value, which is negative 0.942. Okay. So the critical value that we have is let me just copy that thing. So if the critical value, like I said, the alpha would be the testing value, right? So the critical value going to be testing values. So it's basically state inside of the confidence level. So basically we know nothing about that statistic. So we don't have enough evidence to reject the null hypothesis. So let me just repeat what we have over there. So assuming that we have like 62 and 72, this is what I what I seen it. Uh, those regions like HO inside of the region like between 62 and 72, we cannot make any decision. We have no information. We cannot say anything about the test. So we going to like we fail to reject a no hypothesis, right? So anything that makes our analysis stay out of the testing region. So stay inside of the testing region so we cannot say anything. Okay, stay outside of it, yes. So we're going to accept actual no matter what we're going to fail to reject Joe. I'm sorry, we reject Joe. So um in other words, what we're going to say that the test value lie in the rejection region, and no, it does not lie in the rejection regions, and then meaning that the null hypothesis should not be rejected. Okay. Okay. So this is what we have right there. So so this is what we have for the rejection region. So any value that stay in here that we're going to reject null hypothesis, and then we're going to accept H1. So we're gonna basically state that the claim is true. We have enough evidence to perform the hypothesis. Okay. So we have to be in that region. So this is a region that I just pointed out earlier from that example, like between 62 and 72. If any point that is like less than 60, for example, I'm saying greater than 60, yes. Less than 72, 73, 74, yes. But something that stay inside between 62 and 72, we say no. Okay. So that's part of it. All right. So we can try another one. Just put that 1.645 and it's greater than 9. So it's going to be on the right tail. This one tail test. It's going to be on the right side of the test. So we're going to take like 1.645 and there's there's the test statistic value that is given 2.044. So it's gonna stay out of the confidence level. So it basically like in the rejection region, and then that no hypothesis will be rejected, meaning that the mean was actually greater than 9. Okay, so we have to stay out of the confidence level range. So um it's not something that really hard, but just we just have to know like that analysis. Okay. The p-value appro the p basically the p stands for probability, right? So the probability value approach basically instead of just like looking at the critical value, the score, now we're looking at the probability, but the concepts remain the same. All right, so different is different than 9. So we're working on like two-tail test. So we have to do on both sides. So the alpha, we be on both sides. Going to take half of that and half of this. Okay. So what we have was different than 9. So we're gonna test on the two-tail test. Okay. And then we're gonna go for two-tail. The sample statistics that we have was test statistic was 1.728. Okay. And then the p-values that we got was shade the region that represent this. So that will be the p-values on it's gonna be on the both sides. So it's testing on the difference. So it can be either or less. So we have to do on both sides in this case. So this is how we build up the confidence level. And the p-values that we just computed was 0.084. Okay. So each region gonna be like 4.2%. So now we're looking at the alpha equal to 5%, right? So 5%, so that's 5%. Okay. So 5% is supposed to be like 2.5% each. So I know it's really hard to see because the curve doesn't give you that. Let me just show you what it is. All right, I don't think I have enough space for that. Hold on a second. All right, so I just covered some part of it. Doesn't matter. All right, so we're gonna take the alpha equal to 5%, a 0.05. So 5% should be something like that, right? The testing region will be that one. Okay, so this is 5%. Okay, so the alpha is 5%. So now we have to be extremely careful from what we have done earlier. So meaning that um the statistics score is stay inside of the confidence level. So it does not go into the rejections region. So we go into say no, right? So we cannot claim anything. In other words, we're going to say, seeing the p-values is greater than is less than is greater than the level is greater than the alpha. which is 5%, right? The alpha that we took with 5%. Um, so we cannot say anything. So the null hypothesis will not be rejected. Okay, as simple as that. But since alpha, the p-value is greater than alpha, it's simply 0.084 is greater than the alpha, which is what we have for the testing region. So we go into so the actual should not be rejected. So we cannot say anything because stay inside of the null hypothesis, the actual cannot be rejected. Okay. All right. So it stay inside of comfort level. So we have to stay outside of the of that region that we're gonna say yes, but stay inside of it, we're gonna say no. Okay. As simple as that. All right. So we do the same thing, and then so we're gonna have the p-value was 2%, and the alpha that we took was 5%. So 2%. So let me just do that question quickly. Okay, no problem. So you can literally check that the alpha is right here. So we're doing for one tail. We're going on the right side, the right tail test. So this is what we have for the alpha. So the alpha is 5%, and that one is the outside of the confidence level. So meaning that we're going to um, reject no hypothesis, okay, and then we're going to accept the claim. So seeing the p-value less than the alpha, the no hypothesis is rejected. We will never accept a no hypothesis because the no is something that we do not know. Okay, we have no information. The mean can be any point that traveling between that range. Okay, what we want to focus on is, hey, the majority of that probability was not containing the population mean, right? So then we have to say yes for that. Okay, so this is what it is. Less than the alpha, which is 5%. So then we're gonna say then we have to, then we reject the no hypothesis. It's just like when you go to the judge, we go to like the court, and then the judge will never say that person like innocent. The person is not guilty. The same thing. We cannot accept the no hypothesis. We can only reject the no hypothesis. Basically, something that is stay in the rejection region, is stay out of the confidence level, or that we go into fail to reject no hypothesis. Okay, so they're basically two options, but we never accept a no. The no is something that we have no information of uh of the test. Okay. All right. I think that one is kind of yeah, this is basically a Hollis chapter that we have is every hypothesis testing is followed through the same concept that, we estimate a range, something like that. And then this is from chapter 7. And then instead of we doing so, that we're going to like make some educated guess, like create some assumptions, to see whether or not we're going to pull in some hypothesis to see whether or not it's going to work for the goal that we set up, right? So, for example, I give you one example. I want you to know if my class, if the entire Stat 113 campus we have the average greater than 60. So based on the analysis that we have from the class, assuming a class is a good perfect example, you say yes. Well, I mean, the average grade was greater than 60 points. So, you know, that is pretty good. Um, anyway, so let me just go over another um two analysis, and then I will let you go. So it's important to highlight like the key analysis, the key word for that. We need to know what the goal of this question is. Like the goal we want to test um if the mean was less than 21 kilometers. So this is one tail, specifically this is the left tail test. So we're gonna build up the mean was greater less than, you have to start with the H1 first so we don't make mistakes on it. So this is the goal that we're trying to set up. But the main thing that we will never put the no hypothesis, we never put the third hypothesis above the no hypothesis. I know some people might ask me like, why we put a no hypothesis? Because we never accept it. Well, because statistic is all like we focus on the unknown. We do not have much information within like a big confidence level, which is why the no hypothesis always be going first, right? So this is the thing that we have in statistics. And then on top of that, just put the no hypothesis would be equal to um, 21. And this is what we're trying to reject. If we see our data says good enough, provide enough evidence to reject no hypothesis. So it's based on the sample of 85 people. And then we also have the sample mean was 91, I'm sorry, 19.1. And then we also have the standard deviation, which is 8.3. I might not have enough time to go over like two examples or something like that. So I just go like one example, one topic, but we need to understand what it means to us. And then yeah, so we can compute the critical values based on that. So this question just asking us to compute critical value, which is what we did. So this is the left tail is basically 1/12. So 1/12 test is going to give us the negative critical value because the means will always be, that's the sample mean will always be less than the testing population mean in this case. Um, so we're gonna compute it on a calculator, so it's not given. Of course, the question go very slow. I might just do one question, and then if you understand it, then we don't let's just have to do those like small questions. So we're gonna start with the mean was 19.1. The testing mean, the population mean that we had was like 21. Some of you might ask me like why we use like 21. So we might want to compare the current sample size average with the last year population means, or maybe some value that we can come up with. And then there's no reason that we're gonna test on the sample the mean was like greater than 21 because the sample mean was 19.1. Remember that the when people come up with a testing value is always based on a sample information first. So you want to know if the population mean was basically uh less than 21. We're using like a small sample size to make conclusion on like on the entire community. So we're gonna divide it by the standard deviation was 8.3 over radical. We do have a sample size of 85. All right, so we can do that. So we can have the z-score equal to like negative 2.11. So it have to be negative when it's left tilt. And then we can also enter a critical value of negative 2.11. So now the no, the critical value is not negative. The test statistic is negative 11. So this is the statistical values. We call test statistics. Okay. And then the critical value is based on the curve, based on the model that it fit into the data sets. So 10%, it might not be easy to look for that. So you have to be extremely careful. You want to make sure that this is one tell. So 10%, I want to find the critical values of 10%. We can use a chart, we can use a table, but I would prefer people use a calculator so you don't necessarily have to go like forward and backwards when it comes to the exams question. All right. So the significant value, significant level was 10%, right? So we need to find, hey, what is the z-score that associated with 10% probability, right? The critical values can be found on a calculator. We call it the z-score of zero point 0.1. And then for some reason, I just want to make sure that we can double check if this is one tail, two tail. When you use and calculate the z of zero point 0.1, we can get 1.28. So that basically 1.28. Okay. However, since we test on the left tail, so we're not gonna do on this site. We have to do on the other sites. So instead of doing that 10%, but remember the calculator going to give you the right tail area. So if you want to go for the left tail, we're going to go like, all right, this is what we want to test. The Z, I'm going to change the side to negative 1.28. And then, so apparently the, 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 the test statistic score that we found was basically it stayed outside of the conf level, stay in the rejection region. So the negative 2.11 is simply less than negative 1.28. So there's a format for that. If we have the z or the t, that it doesn't matter, is greater than the zc. So apparently that we're going to we have to reject an actual, and we have to state a claim. So stand claim it, and we claim it. Claim it. Okay. If we have the z was less than the zc, so basically it's state instead of comp level, we have no information. The reason why I'm using absolute value, I just want to compare the magnitude instead of looking at the sign. So we go into uh, fail to reject actual or do not reject actual. And then we cannot go with the claims. So we cannot say anything. And then we cannot say anything. Okay. So that's one of the things that we should know. So we only look at the magnitude, right? We look at the magnitude only. Okay. So and then we enter critical values as negative 1.28. So apparently that the testing value is basically fall within the lie in the rejection regions, right? It's lying in the rejection region, the another part is rejected. So there's no evidence. Yeah, that's apparently that we have right here. Okay. The no hypothesis must be rejected. So we have enough evidence to say that. I don't know why I have to. Oh, yeah, just solve it quickly. It have to be 8. All right. So yeah, every single test is gonna be done like this. Okay. And then we're gonna come back to it next Tuesday. Oh yeah, I would mark you present. Yep. All right. So let me take attendance quickly. Yeah. Hashan, you have a quick question? Yes. Jazz is here. Malika, Annie. Malika is here. Rachel, Selena, not here. Hashan is here. Samina, gotcha. Sarah, gotcha. Alexis, gotcha. Z, gotcha. Marlene, Marlene is here. No. Okay. Um, Jocelyn, I think she's here. Valerie, Nadir. Okay. Nico, Tina, Ariana. Okay. Nico. We have two Nico actually. I'm sorry. Um, gotcha. Um, also we have a Karen. Karen. Karen is not here, right? Meet her. Amama. Lisa. Gotcha. Chira. Chira is not here. Okay. Catherine. Gotcha. Chloe. Elkin is here. Gotcha. Yeah, just type yes so I can just, and she just, Damaris. All right. So, William is here. Yeah, I got you. Yeah, just type yes so I can just copy that when it comes to your names. All right, have a wonderful weekend. See you guys next Tuesday. Take care.